Hello, please tell me if you can hear me well and true. Good. So I'm Krzysztof Romanowski. I'm coming from beautiful Poland, beautiful city of Kraków, where I'm there, as Rafa said, I'm head of Scala. I'm also head of tooling, so I'm dealing with both Scala people and like Bazel IDE people. Not much with code anymore, that's a bit unfortunate. And today I want to tackle the problem that, or not the problem, a hot topic in Scala around tools, maybe even build tools, we will see. So, we need to start with something that we all know. Do we all like it? I don't know. I used to like SBT. Now I think it's necessary. And SBT is quite old. By the time what SBT was first time announced, I was still in high school and I have no idea about programming. The only kind of concern of mine was where I should go to the party with my friends. If somebody forced me to think about what I should do in my future, I said I will be a math professor. As you can see, I'm not a math professor anymore, or never was. So yeah, SBT is there. And why Scala needed to have a build tool from the very beginning? Back then, Maven was, I think, on. There was Make for sure, there was Makes Forever. People were thinking a bit about Gradle. So why we haven't adopted stuff like Kotlin? Kotlin just jump on Gradle and nobody thinks about Kotlin build tool. There's few unique things about SBT, about Scala itself. The first one is that Scala compilation was always and is a bit slow right now compared to other things. So if you want to build a build system with SBT, with Scala, you need to have something that helps you with. And that was the incremental compilation. And that was like the first selling point of SBT. It was the incremental compiler. Later on, it was pulled off, named as Zing, and used in different places. That is why we have incremental compilation in Zing. It was added to Maven and so forth and so on. But it was like the best integrated with SBT. Second main driver was play. When I started working with Scala, the play was like starting to take off. And actually working with play and SBT was a pleasure. It was the thing compared to almost writing a JS piece of code, especially if you're working on the front end, because of how well it was integrated and how well it was like refreshed and took to your application. So that's the second thing. And the third thing that we need SBT is because we need to do cross compilations. And we cannot live until Scala 3 without cross compilations. Every so often, Scala releases a new minor version. And it forced all the community to slowly migrate. And you cannot do it like overnight. So people need to support one version, two versions, three versions, and cross compile. Then there was a Scala JS. So one more layer of cross compilations. And to be fair, SBT is good in cross compiling stuff. JetBrains needs to put a lot of work to add multi-platform support for Kotlin, not to mention cross compilation across different versions. SBT handles two-level matrix or even sometimes three-dimensional matrix. But SBT has its age, has its requirements, and it also has a critic. There is this, probably half of you read this blog post from Howie about what's wrong with SBT. I'm not going to dwell into the problems there, but it was written in 2017 and it's still relevant today. It's not because people were not working on SBT, but core, like the design decisions that was behind SBT, changing them over means like complete reset of the ecosystem and actually starting a new build tool. So SBT can be incrementally improved, but I don't think that SBT with keeping what's there in SBT can be drastically changed. And I don't want to say that SBT is bad. Don't quote me on that. I do not said anything like that. SBT is simply a tool that was built for needs that Scala had and still has, with all its pros and cons. But I think it's not the tool that we need in 2023. I will get to the reasons later. We have a new thing new kid on the block. It's called Scala CLI. Is it a build tool? I'm not going to answer that question today. What I want to say is I don't want to call it a build tool. So what Scala CLI is and what it can do. Let me do a quick demo. You have two classes, the test on the right and the code on the left, at least from my perspective. And what you can do here is basically you can just compile the code as you would expect. and run. Actually, by default, you run it. You can provide args. But you can do also fancy stuff, because you, for example, can package. Okay, we got an app. It runs. It will be not really fast because the JVM one. Can we do something better about this? Yes, we could. We can say it use native. Yes. There is something wrong with native. Anyway, can I do something else? Yes, I can do native image. So I can use Gradle. I'm a bit cheating here because I run some of those stuff and it will take actually a while. So I can speak for a second. So yeah, Scala CLI offers this standard things to how you play with a code. It's also like the SIP 46 that Pavel mentioned during the keynote was accepted. And this is going to be the Scala runner. So when you install Scala, you will get Scala CLI. Yeah, so it's there, and as you can see now, it's like super fast. And so you can do more. You can write test without any problem. I should need to provide what I want to run. And we have this thing that is a bit controversial. So as you can see here in the tests on the right, we have the so-called using directive. This is the piece of a comment that actually serves a purpose to provide the configuration. So maybe I will not configure test, I will configure a normal file, because in Scala CLI you can put using directives in any file on top of the file. And what you can say here, you can say here that you want to use Scala 213. I forgot using Scala 213. You can set here, I want to run it with JVM 17. Again, I forgot using. And many more. I don't want to get into all of the things with the Scala CLI, but it's basically a really fluff-free, as I want to call it, a tool. You don't need to think much about configuring, installing, and that's something that is not so common, even with the ecosystem. There go like crazy, great tools. Like if you want to go into the Rust, you still need to use two tools. You need to use Cargo and Rust app. And with Scala CLI, you just go and use Scala, because Scala can configure everything for you. You need to install a few bits. You still don't get everything, especially if you want to go native. But for most of the cases, it's just install Scala and you're good to go. So, what are the two things that Scala CLI miss? Why I'm not calling it a build tool? It's mainly because it's single module. What does it mean? In Scala CLI, you can build only like single compilation unit and single compilation unit of tests. You cannot add a common module and three different modules that depend on each other. And you might ask, why? Why such a limitation? The answer is simple. We made a decision when we are designing Scala CLI so that everything that you can configure within using directives or any kind of persistent configuration, you should be able to do it from the command line as providing an options. So there is like and command line options take a precedence. So if you configure a Scala version in the using directives, you will, if you run it with Scala CLI -Scala something, that thing will take precedence. And that's really important for the Scala CLI. That's like the main design philosophy, to make it simple and make it like this good command line citizen, so it can be integrated in other tools later on. And adding a multi-modules there, it's super hard, because then you provide inputs and you need to split into two groups, provide dependencies between them, share configuration, and all of that you need to do within the command line. Not an easy feat, and we don't want to do that. And we are actually quite happy that we take this approach, that we focus on the command line first approach, because it allows us not to do a feature creep, because there was many features that people proposed that actually we can say no because of the command line first approach. And the second thing that I don't want to call Scala CLI a build tool is because it lacks extensibility. Scala CLI is designed to be composed with other stuff. So basically you can write and make with Scala CLI inside, but you cannot extend Scala CLI itself from the within. And that was, again, design decision. I mean, you say, okay, it is limiting. It's not. For us, it was all about that Scala CLI is simple. And when you see like classes, you should expect how it works. With plugins, and that changes the behavior, you can have anything and you will be confused. And that's one of the problems with tools like SBT and Gradle. I will get into that. So Scala CLI has no extensibility, so it cannot really be a build tool in my sense. So within the build tool, I show you a few things. I show you compilation, I show you the dependency resolution. I mean, it was not direct because we have this the toolkit thing there. We can package, we can run the code, we can test the code, we can format the code, and we want to check the code as well. We would like to publish the code and maybe even deploy. That's sort of the main top-level things that you want to do with our build tools. Are you using anything else that I missed? Obfuscate? Obfuscate. So, oh, that's a good one. So it's sort of a package thing, I guess. It's like custom packaging, but yes, that's a good one. I don't do obfuscation for ages, but some people still need to do it. I think JetBrains get a huge problems with IntelliJ. They need to obfuscate few things and detect obfuscation because a lot of people were like, pirating it out and using it without paying. So, which is not good. There is also, of course, there is also multi-module support and other stuff that I will get into later. So, SBT, Gradle, Mill, namely any other build tool, can do all of those stuff. They are designed to do it well. So why this presentation should not adhere, like basically pick one of those and go home and just improving it on a daily basis. So, starting with SBT. SBT is slow. It's not because it's badly written, but it's because of the model it has. Inherently, SBT had, and yeah, also like how he was describing that in his blog post, it has these 3 layers of interpretations. It's JVM applications. And the biggest sin of all there, it's not a sin, it's a feature, I would say, is that it allows custom plugin, custom code. So you need to first like compile the code that you define, then interpret and then run it. And also the code that you write in your build tool as your build configuration can do anything. So you cannot optimize it really well because the user, not knowing what is being done or something, can actually make it infinitely slow. And SBT is like really, really hard to learn. I don't know how many of you, maybe you can show hands, actually things that knows SBT. Okay, three people in the room, okay. All of those people are like open source maintainers. And that's actually sort of when you think and you speak with people, this is a pattern. Open source maintainers, people working heavily in open source need to know SBT. And SBT is quite good for working with open source because the builds there are quite complex. There's like multiple dependencies, reusing multiple modules, cross-compilation to tons of the targets. I mean, I have huge respect for everybody maintaining a multi-module library like CATS-effect, Zio, whatever, because of how complex those builds are. Not to mention Scala Compile, Scala 3 compiler, when what they need to do is basically compile the compiler to compile the compiler again. And that's only possible with SBT. But this complexity and the fact that they need to have a task system with macros that allows it to be fast, not to repeat the work, means it's also hard to write and extend. Because if any one of you ever tried to build anything simpler than like call 3 times value on a task in additional task, want to like pipe them or something, we'll get into like flat maps, task definition, and other stuff, and that's really hard. And that also means that this is hard to maintain. I go through like probably 20 or 30 different SBT builds for like open source and commercial ones I haven't seen before to prepare for the stock. And in few there was like a scary patterns. Like my favorite scary pattern of SBT, there is a piece of code that plugs into the very heart of the SBT, the task resolution mechanism, and do some stuff there only to install Git hooks. And imagine that it broke, and somebody that wrote that code is long gone from the company or project. Would you be able to fix it? I don't want to be that one because that's scary. And that's how some of the SBT builds are. And also the complexity show is like, if that's code, so people write this fancy DSLs on top of SBT. Maybe maybe you have some fancy DSL on terms of like project definitions in your builds. Maybe you can show your hands if somebody has that. Like, you don't write a project, but you write like my project with dependencies, and if Scala 3, you write something else. Yeah. And probably everybody have something like a BOM, some bill of materials from Spring, when you define dependencies in the object and then use the variables into different builds. And everybody doing it slightly different. That's the SBT. That's sort of the power, the beauty of SBT, and also where the problems with SBT are. And there's a Mill. Mill is an improvement on top of SBT. It learns from years of working with SBT, fulfilling the pain that I described, and try to improve of all of those. It's still slow because it's also a configuration as code, but it's heavily with caching. It's optimized a bit, and the module is simpler. It's, I shouldn't say harder, I should say easier to learn than SBT. Sorry for that. Because parts, the code is simpler. There are still macros, but they are much more user-friendly than what we have in SBT. However, there is not that many documentation. SBT have a huge documentation compared to Mill, and with Mill, what you do is basically you go through the code of the Mill itself. And the Mill has the same problem as in SBT. It's also hard to maintain. It takes a bit different approach, because it's more like classes and objects that you combine. So this sort of DSL things are less common in Mill. It's more like a code, but still, it's a code that has some semantic that you need to know in order to maintain. And this is, I mentioned the documentation, but it also lacks a bit of the commercial adoptions, because I talk with many commercial applications and developers from there, and pretty much none uses Mill. I mean, Mill is good. We are using Mill to build Scala CLI, so it's not like it's wrong. For some reason, people on the commercial side of things prefer to take SBT. Or Gradle. Gradle might be a good option there as well. It's SBT and Mill doesn't have this kind of strong corporate backer right now. Scala Center helps with SBT. There is active community around Mill, but there's Gradle Enterprise for Gradle that provides, it works with caches. And Gradle, by default, still like there's like dynamic language in there. There is a Kotlin DSL right now on top of it, so it's much better. So it's like, you don't need to like think that you got a typo and your build will not work. And I have huge respect for everybody working on the core of the Gradle, because from all these 3 build tools, this has the least in terms of safety, what provides the design of the tool itself. But they were able to actually take and introduce caching to a build tool that has no support for caching initially, and get it to the level that you can cache builds between machines. Of course, you need to pay for that. That's a product. But yeah, I have a few respects, and I'm pretty sure that it's really hard to maintain to make it work. But yeah, the Gradle is an option. And the biggest problem with Gradle for me is that it's too easy to extend. Because especially if you go away from Kotlin, or even with Kotlin, it's super easy to write build configuration that you pipe the things together, and it looks good, it might work good in one machine, and then it will break. In some cases. So people are like sort of tempted to write custom stuff with Gradle because it's less scary than SBT or Mill, and then you need to maintain those stuff. So basically, on the Java side, when people use Gradle heavily, there is also this kind of battle story that I waste a week of my life trying to find this problem with our builds. It's just because it's how hard it is to maintain a build system that is inherently a code. So what are the expectations for the build tool of the future? What I want to have in my next one? First one, I mean, maybe I'm biased because of all the Scala that I used to do in my past, but I want that thing to be blazing fast. There's nothing worse than starting a build and waiting for 40 minutes. I think people like Optimus Sirius, like Adam and Jetta can confirm how, like they mentioned during the presentation, how actually agonizing it might be to wait for this kind of, for a build to do anything, just to learn that you do a typo in one spot or something. And I'm not talking 40 minutes, I'm not talking minutes, I'm talking milliseconds. No build should take milliseconds, no question asked. And as an experiment for preparation for the talk, I want to actually compare how fast I can go with Scala CLI compared to, let's say, SBT. And what I did, I pulled like part of metals called mtags. It's all the pieces required to, code completion and stuff like that. And I want to have something that is on the library, basically. I pull it off from SBT and write for each module there, I write Scala CLI definition. And then I piped 5 of the Scala CLI builds. I like produce a jar, consume that jar, the next one, resolve all the dependencies configuration. It's really not an efficient way to have a multi-module project. And it takes around a second that way to get these things checked, nothing was changed, package, and start the test or application. With SBT, as optimized, should be optimized for all these cases, it's 2 seconds from console. And if you start a console, you have everything warm up, it's still 1 second. So as you can see, there is the modes or the interpretation and writing. We need to get better. Also, I want a tool that is that simple to learn and use. I just want to see the configuration, key values, something, no documentation, nothing, just type few things and it works, or not, or I get an error that is meaningful. also, I want stuff to be opinionated. I don't want in my build tool that there is 10 different ways to do the thing. I want to like achieve like a pipe two dependencies together, or even worse, 10 is okay. But if there is a way to, I can invent 11th or 20th version of that same thing, that's where the scary things about build tools come in. And at last, I want it to just work with my terminal, with my ID, my CI, no fluff, like setting up a configuration and so forth and so on. It sounds a bit like Scala CLI. Probably no, I'm biased. I was the part of the team that was working on it. But in the end, if you take the commercial projects, big stuff, it sounds like, unicorns and rainbows. No way that you can have that thing. And if you ask me like 5 years ago, I would say, yes, that's unicorn and rainbow. In this industry, we need to suffer. There is no other way, like we need to suffer. But then I saw a few things and I noticed a few things. Like, I was working as a part of a team building a build tool. It's like closed one. I cannot show it. I wish I could. And we sort of apply the lessons I was showing. And we're able to get the results. It's not because of the build tool design. There was other things in there, but that's possible. That's not the kind of, fantasy reality generated by DALL-E. And there is also Rust and Go. That's, if you look at how Rust and Go builds are configured, they are pretty much what I described. Configuration only, really fast. And developers generally like their tools. I was like, as a part of preparation for fun, after like 2 hours or for like researching stuff, I just start asking ChatGPT, what are the problems with 5 most important problems with, I don't know, SBT, the cargo, so Rust build tool and stuff like that. And the answer was sort of always the same, like the lack of documentation and so forth and so on. But when I ask for cargo, it says, cargo is generally liked, but it has few problems that are probably affecting some people. And that was something else, because ChatGPT suggested that cargo is liked, even though I don't ask about it. Later on, it gave me a different answer, so it's not like kind of a proof or something. But there's a sentiment, especially for Rust, that cargo is good. And I would argue that cargo is not a build tool. It doesn't call itself a build tool. It calls itself a package manager. Same with Go. Why? Because they lack what I described there for the two features why Scala CLI is not a build tool. So there is a support for multimodule, but not in the sense as you know it from SBT or Maven. But you basically, pipe the things together so they are dependent on each other, but you cannot depend from task resolution from module A in module B, or something as that is like, from module C can affect some other task in module D. It's only about like, there is a package and I depending on that package and move on. And with Go is the same. And as for extensibility, for Rust, we don't even have a plugin per se. You can install stuff in Rust, but it's more like a courtier, like a stuff to install application and like convenient way to run it in the context of the build. And the cargo doesn't even expose an API. Basically, every cargo plugin needs to read configuration in its own way. So, is that what we want to do? Do we even need a build tool at all? And let's come back to the Scala CLI. So the things I showed, it can do all of that. Maybe except for checking the code. We don't have a support for Scala fix yet. It's going to be there. We cannot deploy the code. We can in some definitions, but Scala CLI is close. And I just want to argue, and I'm happy to discuss it after a presentation with anyone, that I think Scala CLI is better than what we have in some regards in cargo and what we have in Go. Mainly because Scala CLI is self-contained, so it can provide all of the configuration itself. And on the other fronts, we got pretty much the same. We only miss that these little tiny bits about the code generation and about a workspace support. And this screen is from one of the libraries that some of my people are working on, like a new experimental project. And this, as you can see, they got like cut score, Zio, and stuff, different set of things. And they are not using SBT. They hated SBT. and they just decided, okay, we will go just using make and Scala CLI. So there should be a way to create multi-module builds with Scala CLI, especially if you take into account that Scala CLI uses Blip under the hood. And Blip by definition is multi-module. So it's just a matter of orchestrating in the right way. And then we go to the harder problem, or apparent it might be harder or seem harder. That's extensibility. And now to answer, like, do we really need to be able to plug stuff into SBT or like any build tool? We should look probably what we want to plug, what we want to do, because that's the thing that I think we are missing in the build tools. So first, the simplest things, like we want to generate sources, you want to generate resources. Unfortunately, we cannot compile code straight from protobuf definitions. We need to generate code from that. And that's how the world go. I wouldn't expect that 10 years ago, but there is a lot of code generation going on right now. So we need to accept that. And it will be added to Scala CLI at one point with like really well-defined extension point, like basically you just write a command line application to Scala CLI to generate sources. We also want to generate resources. Resources are sort of like sources, but not used for compilation, used for packaging. Then we also, another thing that is super common that everybody is doing this SBT build is to reuse configuration between modules, to define common stuff. And then you think, okay, we need plugins, that's a complex. That's complex only if your build is an application. If your build is key value sets that you can basically compose into a monoid and then pick the one based on some kind of fixed rules, or basically if you got two versions, you just define a conflict or something, that's not a problem anymore. We are doing it in Scala CLI because we have command line options and using directive options. So adding like sort of a common shared of options somewhere should work. Then there is this, a lot of people do aliases, and that's really good. I just want to like type deploy rather than remember I need to compile this to Scala 212 and that to something else and package, like obfuscate, let's say, and move it to the server. So I want to have like alias for a set of tasks, or even extending that concept, I want to create a script. And I think that's the most where the 90% of the extensibility actually falls into. Being able to script like preparation for a test. So I just want to build a server, start a database, and run tests with that, with like piped arguments. I want to do a deployment in the way. And for that, you don't need plugins, you need scripts. And okay, so I can use Bash, but Bash is not really, fun way to work with. So if there is an API, let's say, it might work. And the last part is like a lot of people validating the builds, like checking if it's like licenses are okay, if the jars are not too big. There are different things that they do, or like maybe like restrict some of the dependencies from being packaged. And that's actually a script and custom packaging. So the scripts can also handle that. So that's the kind of the most important thing from this talk. Let's have an idea that we can extend or build something on top of the Scala CLI that can basically compose Scala CLI builds. So we will chain multiple Scala CLI builds, has this sort of similar semantics, similar key values, and the same keys, that's critical, same keys as Scala CLI use. Then we add a module-oriented CLI. So it's not like, we provide configuration on the fly for a given module, but you can, select a module. You will select what kind of module do you want to run based, where you are in the code, and so forth and so on. Then we want to add a configuration file or files, a central one, and probably even turn off the using directives. Because hunting using directives into the kind of thousands of lines of code across hundreds of files, it's hard. And using directives are really good, and they are needed for the what this kind of use case of Scala CLI, basically be able to provide like condensed context to do something. And then if we provide an API and like nice ways to write scripts using API that we already almost have, command line options that we need to provide, we need to maintain them backward compatible and validate, so you can just type them in some kind of, I don't know, case classes, whatever. Then we can just add a few wrappers on top of the running stuff and maybe changing the configuration, and maybe add a few bits about like watching. And we have like a really powerful utility to write scripts that interacts with the build tool. And not scripts that are like tied to what you have in your build tool, but this small library can be cross-compiled to anything. So you can have, I don't know, Scala 212 scripts in Scala 3 build. And as a developers, we mainly build applications, and their script will be an application that will use an API. So this is something that people understand, that people know how to deal with, rather than like, getting this funny models or like tasks and dependencies and macros. And Scala CLI is actually really good at handling with scripts. So you can imagine that you can write the script like this, add a directive to say, okay, that's a script in my build. I want to compile it to Scala native and use, I don't know, this and this and this dependency. And the first time it will take, I don't know, 10 seconds to run that script. But after that, it will be cached. So you get a script that you write in context of the build tool that should be like instantaneous to run, and the build tool that should be super fast. So I hope that things combined can give you this kind of impression that what you write is a natively built build tool similar to Make or something, but you are using Scala, which is super powerful. So is there a blip of hope? There is a build tool that is being still developed. It's really early phases. It's called Blip. And I was like preparing for this presentation, having this model in mind, and I'm reading the documentation is like exactly what I wanted to show you here. Basically, build as configuration, scripts, fast native application don't run stuff. There is a few differences, and the project looks really promising. And the main thing I get from that, the fact that Blip exists, is that I'm not the only one that has an idea that something like a configuration-only build or like package manager is a solution to the problem of our build tools. And then when I was showing this presentation to some of my friends at Virtus Lab, preparing for this talk, they asked me this basically, like, you got 14 build tools in Scala, so why do you want to create another one? And yes, you might look at this that way, but this is something I learned from actually looking at Mill and what Mill does and why, and the question is why Mill hasn't succeeded as much as it should. It's mainly because it was just a slightly better in many regards than SBT, and SBT was entrenched in the community. So in order to change the situation, you need to provide something that is completely new. To give it an analogy, we can ask a different question. Do we need another kind of drill? That drill, it was designed probably like in Paleolithic times or somewhere earlier. It works. Why do we need something else? Why do we need to think about this? Or later, like middle of the 20th century, why do we need any kind of drills? We got this nice hand tools, like, craftily made. We got this big constructions things that you can drill through concrete. We have this precision like drill presses. And that's good. That's what we have right now. But what I think, what is needed and why I want to design and build, hopefully in the future, a build tool that will be more like this. Like a battery-powered drill that you can take, that is super easy to use, and you will use it everywhere. Look at the construction workers. Everybody gets 5 of those right now. I got 2 in my house. And I think Scala community deserve to have a tool like that. Thank you.